Hey, hey Sophie and the LFDT team, myself Darshit. You already have my 2-page task response, my 5-page architecture plan, and the interactive website. So I won't be sitting here and wasting your time. Instead, I'm going to explain you a quick overview of my whole architecture and plan. So here, the goal is not to rush a messy migration. Our goal is to build a robust V2 GitHub app from the day one itself, like and expand it module by module. And the very first slice we are going to build is the slash design. Let me take you through the core architecture in this diagram. Here, when a webhook comes in and it hits our listener, so this is the absolute trust boundary. Why? Because it is a very important, like it is a, we can say, a bodyguard for our whole architecture. Why? Because it verifies the HMAC SHA signature and immediately drops a forced payloads. Okay, simple. Now the normalizer abstract this payload. Here the normalizer abstracts this payload, and then the router pushes back to the dispatcher. Here is where our architecture is important. The dispatcher pulls repository specific rules using the config engine. This config is not code. It is a typed policy file owned by each repo, each SDK repo. Like in each of our SDK repos, there will be a config file. It is like basically the setting for each of the repos. Now the dispatcher then hands the event to the policy module. This is the flow. After this is an important part of the design. Policy modules are a pure decision function. This is very important. Pure decision function. They hold no credential. Their only job is to give decision. They are not involved in API calls and all this. Their only task is decision. Finally, the executor handles the actual GitHub API write. Executor is used for the actual GitHub API write. It is like the policy module is used for the decision, and executor is used to execute the whole task. We can say in simple words, in layman words, like policy module acts as a judge and which gives us decision, and the executor acts as a police which executes the things. Now finally, after the executor handles GitHub API write, audit logger, this is very important. In each of these stages, if we see all of these stages, audit logger is used already, because in each of these steps we are console logging continuously so that we can catch errors and debugs. Now let us answer one important question. Like, let me go back to the notes. Why are we starting with slash sign instead of PR quality or review sync? The answer is because slash sign forces that entire 8-stage pipeline to work end to end. Like it touches comments, permissions, maintenance overrides, and config limits. If a slash sign works flawlessly, basically we can say that app shell is already proven. From there, adding lifecycle automation or progression logic is just like plugging new modules. Like all the remaining things will become the plugins for our whole concept, rather than writing the isolated states. But why build it this way? Like, why are we focusing so much on the security? Let us look at the recent PR attack which you just sent me earlier. Yeah, I have already opened that. Yes. So the architecture is specifically designed to kill these types of exact attack vector. First, config injection is architecturally impossible. The app never reads policy from a contributor PR branch, only from the protected default branch through the API. Secondly, because of policy modules, we earlier talked about what are policy modules. Policy modules are pure functions. Untrusted PR code never executes in a privileged context. And thirdly, that all writes go through a single executor that handles idempotency and rate limits, completely preventing the bot loops. Now, let me show you. Yes. So finally, I want to show you that we are not just talking about the code idea. We are also talking about the migration strategy. If you look at my repository, here I have like raised several community issues, which we can see here, 5 issues. I think so that they are a good start to like start building the product in a community friendly way. So this allows the contributor to start building safe things like test fixtures and documentation without touching the production automation. Now The main idea here is simple. Hiero should go back. Yes, Hiero should Hiero should not maintain dozens of independent Bash and Python scripts forever. This is the core idea. We need one well-tested GitHub app with reusable policy modules and repo-owned configuration, that config files that we talked about. I'm incredibly excited about the chance to build this carefully with Hiero maintainers this summer, starting small, proving each piece, and learning a lot through the whole summer term and the whole 6 months period. Thank you so much for your time, and I look forward for your feedback. Thank you.